Now we got for x in range, and then if you put in just a number 5, then that's the ending value. So if I print in x, this should, I think, print 0 through 4, but we'll see. Yeah, 0 through 4. Oh, is it? Okay. Hold on a second. Actually, let me go grab a drink.
It needs your password as well.
Oh, really? Why? Vendor firewall. Now, you can have embedded items here. So for x in range 5, for y in range 4, for z in range 3. Then you can print x comma comma space. Let me think. Then comma. We'll see. Yeah, comma's fine. And it prints all these values. One of the programming projects I'll give you is to create a pyramid of cubes, and you'll use this concept here. On Blender, if I look at my axis here, that's assuming I haven't rotated this, and I don't know if I have or not. Let me do an in location, and that's 0, 7, 0.
Should I pull up all that?
You can. If you do, do the drop down here and choose scripting. And then I had the cube selected, so I right click on it, and if you press what was it, in, it'll bring up this information.
What's the bottom right one? The gray area. Is that anything?
That's info. So if I choose info,
Alright, I got it.
this helps us with our syntax.
Yeah, I got it up now.
Okay. So now if I did a G and I did Y, move it over here, I can move it clear over on that side, and I see that it's -8. If I did a GY, move it over right here, more or less. Okay, we move it to -5. So I'm going to put -5 in for my info, and it'll take me exactly over there. View perspective. There it is. Now I can see it. Do you see what that's equal to? Two of those squares, right?
Mm-hmm.
So then, if you wanted to build a pyramid, you'd have to know what each of those distances for those squares. So let's change this to -6 and see where it takes it. So there's -6, and then here's -5. So how big is that cube? 2 Blender units?
Yeah.
And it even tells you down here the dimensions.
Yeah.
But
what I was looking at.
yeah, so that helps you. Now, if you have other objects on there, you can eyeball it, or you could look at the dimensions here. But when you're trying to plan out, remember last time I didn't put that time into it to study it, and I was having them within each other, and so then I had kept playing with it. So a little bit of time up front there, you can think about what do I need exactly. So 1, 2, 3, 4, 5, 6, 7, 8. So this goes from -8 to +8 on both the x and y axis. So if I was wanting, and you have to modify this as appropriate, I'd say for x in range, and I'd go from -8, comma, and then I'd put I think it's comma, if I had a memory, 9, and then I'll print x. I believe that gives you -8 to 8. Yeah, gives you -8 to 8. I think if you put a 2 in here, let me see if that's true. It goes by 2s. Because if you're wanting to control the position and your cube is 2 in length dimension, you'd need a 2 there, wouldn't you?
Mm-hmm.
If you want a space in between them, instead of 2, you might put 3 or something. So you play with that accordingly.
How do you run it again?
Oh, you can't really see it here, but there's a little green triangle up here.
Oh, okay. Yeah, I got it. There it goes.
Or you can do run. So, for example, if I wanted to create cubes going across the page, well, first off, I need to figure out how in the world to do it. So I'm going to do an X for delete that out. And now I'm going to do a Shift A, Shift S, Shift A, Mesh, Cube. And this down here gives me the syntax. bpy.ops.mesh.primitive_cube_add. So if I come up here, I got my import. I can say for x in -8 to 9 going by 2s, like this. Then I'll say bpy bpy.ops.mesh.primitive cube add radius is equal to 1. I'm not sure if that should be 1 or 2, but we'll see. I think 1. We don't typically think of radiuses on working on cubes. That's more of like a sphere. But I'm assuming it's the distance from the center of the object out to the outer edge. And I think all the rest is optional, except for my position. So location, and I don't know if I can put a space, or inner there? Probably not. Location equals x, y, z, I'm assuming. So I'll put x, and then y would be 0. Z would be 0.
Does that have two parentheses at the end of that?
Yes, it does. Now I'm going to delete this. So I'll delete that. And let's run and see if I have any errors. Now I got some real issues, looks like. G. For x in range. What it did is it created 3 cubes because that's what I told it. If you don't put the range, it'll assign x to -8, x to 9, x to 2, I believe. Okay, so now let me delete those. And now if I run that, you see we got our cubes going all the way across. Now if I click each one of these, you see they're right next to each other. Since I actually evaluated it. That's what it did. Is that on? Make sense?
Yeah.
Now, if I wanted, let's see, y, z goes up. If I wanted it to go up, I would have another for loop. For z and range, I'm starting at, I'm not sure what I'm starting at. It's either 0 or 1. I'm going to say 0, comma, and then I'm going to go up to 4 by 2s. Now again, when you do an inner, you do not want to get rid of the extra spaces because in Python you have to have those spaces there. That's what tells it it's underneath that. And then I come over here and I change this 0 to a z. And what I'm anticipating is it's going to go 3 rows up. But I don't know where it'll start. If it'll start flush with the axis here, or it'll be below or above. So let's see. I'm going to delete all those. So I'll do an A twice to select those, do an X for delete, and now I run those. And it looks like I was wrong. It went up 2. Let me see. First time Z would have been 0. Increased by 2. Oh, this has got to be 1 greater. So I'm going to 4. I have to go to 5. Okay, so let me do an A twice to select all those, X for delete. And then I'll run that. There we go. So that gave us a total of 3 in height. If I rotate that though, what do you notice about them? They're starting below that plane, aren't they? That's what I was kind of worried about, whether they would or not. So instead of starting at 0, 0 is like the exact center, that x value. So that means it went down to -1, went to +1. So instead of starting at 0, I want to start at 1. Which probably means I want to increase this to 6. So now if I select everything, delete it, and run it, Now I see that they're no longer below the plane. Now I could throw the other dimension there. I could throw z in there. Z. Y. For y in range. And I'll say from 1, no, I'll say from -8 to 9, and I'll go by 4s. Just changed up a little bit. And then I'll come here. And I'll change this to XYZ over here. Select everything, do an X for delete. Go to run it now. And you can see it created our cubes. X is solid, and then Z is going solid up. But then the Y's, I increased it by 4, so that's why you see spaces in between these. Now you don't have to have just the one here. You could have something on top of that then. So you could have a drop another object on top of it and continue. For example, this is how you add a cube. So let's take a look at how you add a sphere. So let me come over here. I'll delete all these. Do a Shift A, Mesh, and I'll choose UV Sphere. And that's bpy.ops.mesh.primitive_UV_sphere_add. So I can say bpy.ops.mesh.primitive_UV primitive_UV_sphere_add. Size equal to 1. It's interesting, I'll use radius. And now I'm a location again. So location is going to be X, which is say 0, Y, which is 0, and Z, which we'll say is above all that, 6. And I can run that. We got an error. Location unknown. -1. Oh, location equals.
I have location equals. That didn't work.
It didn't work?
No. Must have something wrong. Or 2. So that makes it wrong.
Maybe missing parentheses or something like that?
Yeah. Or I spelled something wrong. So add size location. 0 misses. Says location. Oh.
You see it?
Yeah. Oh, okay. We'll be deleting the whole thing.
Oh, okay.
That's nice. Oh, BPY.
This editor is still just as primitive as it was back some 10 years ago. I would love it if it had code completion. It'd be so fantastic to actually type in bpy.ops dot, and it pops up with all the different items you could choose. Then mesh dot pops up with all the different items you could choose.
Yeah.
Suppose I could quit being so lazy and volunteer for the project and put that code in myself. But it's easier just to complain. Now I'm going to select all that and I'm going to delete it. Now notice all of this right here. bpy.ops.object.select all, action equals toggle, and so forth. So you could actually have it delete right here. So bpy.ops.object select all, action equals toggle, and again bpy.ops.object.select all, action equals toggle, bpy.ops object delete use global equals false. This is where you need to look at the documentation. It could be use global equals true, maybe would automatically delete everything on your screen anyway. So if I ran this now, you see nothing happens. Click it again, nothing happens because we delete everything. So that's what this does right here. There's this website called Desmos. Have you ever played with Desmos?
No.
It's a math site. You click start graphing here. And there's a graph, y is equal to x squared. That looks like this. So if I'm trying to create this pattern here, and maybe I'm going to drop spheres on here, then I could use this right here to help me figure out how to do it. So maybe I want to go for x in range -4 to 5. Y is going to equal to x times x. And now I could create a cube or a sphere. bpy.ops.mesh dot.primitive uv sphere add size is equal to 1, location equals x, y, and z. I'll put in a 0. This simulates y is equal to x squared. So let's run it. And you see it's got a parabola shape to it. You'll notice that right here they're really close to each other, but here they're further apart, which is the nature of y is equal to x squared. Your points are further apart up here. Down here they're closer together. I could change this to go by 0.1s. So I'll change that to 0.1. And then run it again. It does not let me go by 0.1s. That's disappointing. We have to use a while loop then. We really haven't talked about a while loop yet. Okay, so I'll just stick with -4 to 5. Did I put 0.1 or 0.1? Nope, it doesn't like that. Okay, I'll leave it that way then. But that creates a pattern. Now over in Desmos, how you get that power is if I type something, I do y equals. You see there's a show keypad down here. You can do that. And if I do x, and then I can do this power down here, this a to the b, and I can put whatever I want in there. 3, 4, 5, so forth. Questions on that?
No.
You got all this code, or do we want to print it?
Yeah, I got it all.
Okay. Well, the two things I want you to do is I want you through script and put these in two different Blender files. I want you to create a script that builds a pyramid. So you have to think about what do you do with your for loop and so forth to get that to change. Now, I will tell you, to build a pyramid, instead of hard coding these values here, you can have it go one less than x in some cases. So you can play with those. Now, you may have to have multiple for loops if you can't figure it out using that. Does that make sense?
Yeah, just the big period, pyramid, and script.
Right.
Yeah.
Like this might be x plus 1, and this one might be x minus 1.
Yeah.
So you could actually put variables in there. If you can't do that, then just have a bunch of for loops. And then the second thing is to create some kind of pattern. So come over here to Desmos and just try to experiment. The y equals x to third power. Third power would be fine. Now how you do that then is if you got x squared, you notice I put x times x. How about if we had x to the fifth? We would have 5 x's, right? Like that.
Mm-hmm.
There is a way to do an exponent, but we'll talk about that later on. But that's a very easy way to do that. But those are the two items. Create some kind of mathematical pattern with spheres, and then create the pyramid.
Okay, so I have to do what you did, basically?
Right.
Spheres? But isn't that what I just did too?
Yeah, it won't take much of a change. Something besides x squared.
Something besides x squared?
Yeah, like you can come over here, you could have y is equal to x squared plus 3x minus 2. Or you could have x cubed minus 5x plus 2. So I could have that right there. X cubed minus 5x plus 2. I would have x cubed minus 5x plus 2. Now, if I ran that, you see how we get that pattern there?
Yeah. I can't really tell what it is. It's supposed to be.
That's
like
what
it is in Desmos? Oh, yeah, no, I see it kind of. I mean,
yeah, it's not so easy. Let me see. It's going down. Not that I'm smart enough to flip it over, but it models this more or less. Doesn't work real well when you got big spheres like that. They're so far apart. But since we haven't covered while loop, so yeah, don't stress. It won't look exactly like Desmos. There, I can get it a little bit. You might look at this, compare that to this, and you say, well, it doesn't go up as high. That's because once it went to the next value here, they just it ignored all the detail up to here.